Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6 and today we are going to present our project entitled Composite Panel from Manufacturing Waste. Our team consists of 4 students which Nur Alia Ayuni binti Hamlan Hadi, Aimi Atira binti Mat Azam, Nurul Inta binti Ismail, and Ivy Tan Chi Ying.
My name is Nurintan binti Ismail. Today I will be present session 1 with the project management plan for our proposed project title, which is Composite Panel from Manufacturing Waste. The main problem addressed by this project is the increasing amount the fly ash waste generated from power plants and manufacturing industries. Most of this waste is disposed of in landfills, which can cause air, soils, and water pollution. Therefore, our project aims to recycle fly ash and convert it into composite panels that can be used for wall and flooring applications. The project scope includes collecting fly ash, processing the material, fabricating the composite panels, and evaluating their strength, durability, and usability. The project location is focused on the northern region of Malaysia, specifically in Perlis, Kedah, and Penang, because these areas are close to industrial zones and provide a stable supply of fly ash. This location also supports efficiency transportation and has a growing construction industries. Moving on to the project schedule, our project is planned over a period of 14 weeks and each activity is arranged systematically. In week 1 and 2, we conduct research and project planning. In week 3 and 4, we collect and prepare the fly ash materials. From week 5 to 7, we carry out the material processing and develop the composite mix. During weeks 8 to 10, we starting to fabricate the composite panels. Next, in weeks 11 and 12, we perform testing and evaluation to determine the panel performance. Finally, during week 13 and 14, we complete the report and prepare for the final presentation. So in this schedule helps ensure that every task is complete on time and according to the project objective. Moving on to the next slide is the network diagram, which show the sequence of activities throughout this project. The project starts with project planning, followed by material identification and fly ash collection. After that, we collected fly ash is prepared before develop the mix design. The next stage is final fabrication, followed by testing and evaluation to determine the mechanical performance of the composite panels. After the testing is complete, the data are analyzed before preparing the final report and presentation. So this network diagram also represents the critical path where every activity depends on the completion of the previous task. Therefore, if one activity is delayed, the entire project schedule will be also affected.
Next, I will present the risk assessment for our project. The first group of risks is related to raw materials and product performance. The first risk, raw material supply, where the availability of fly ash may become inconsistent or insufficient. This has a medium probability but a high impact because it can interrupt production. To reduce this risk, we will establish agreements with suppliers, secure multiple sources of fly ash, and maintain a buffer stock. The second risk is material quality variation. Since fly ash and waste carbide lime are industrial waste materials, their properties may vary, which can affect the quality of the final product. This risk also has a medium chance and high impact. Therefore, we will perform quality control tests and standardize the material processing before production. The third is product performance failure, where the composite panels may not achieve the required strength or durability. This also has a medium likelihood and high impact. To overcome this, we will conduct extensive laboratory testing, optimize the mix design, and ensure the product complies with construction material standards. The second group of risks focus on production, workplace safety, and market acceptance. The first risk is production process issues, such as cracks, uneven composite panels during manufacturing. This has a medium probability and medium impact. The mitigation strategy is to implement standard operation procedures and provide proper training for workers. Next is health and safety risk. Workers may be exposed to dust and chemicals while handling waste materials. Although the probability is medium, the impact is high because it involves worker safety. To minimize this risk, we will enforce the use of personal protective equipment, provide safety training, and also ensure proper ventilation in the workplace. And the final risk for the second section is market acceptance. Some customers may hesitate to use recycled construction materials due to the concerns about the quality and also reliability. This risk has a medium probability and medium impact. And to address this, we will promote the environmental benefit of the product, provide technical performance data, and also obtain the necessary product certifications. The final group of risks includes cost overrun and project timeline delays. So what is this? The first risk is cost overrun, where production or processing costs may become higher than expected. This has a medium probability and medium impact because it may affect the overall project. To reduce this risk, we will carefully monitor the expenses, optimize resource utilization, and also prepare a contingency budget for unexpected costs. And the last risk is project timeline delays, which may occur due to delays in material supply, in production, or laboratory testing. This also has a medium probability and medium impact, as it can postpone project completion. The mitigation strategy is to develop a realistic project schedule, to monitor progress regularly, and to maintain clear communication with suppliers and team members to ensure activities always remain on the track.
So, for section 2, we are going to start with cost estimation. So, the initial investment for this project is about total investment amount is 80,000 ringgit. So, the direct cost in the indirect cost. The direct cost is high grade chemical binders, which is 2,500 ringgit per month, which with labor budget around 6,000 ringgit per month. So the total is 8,500 ringgit per month for the direct cost. And for indirect costs, the fly ash collection and transportations cost about 1,500, while the processing equipment is about 7,500. Then the molding tools about 3,000 ringgit. The testing is about 2,000 ringgit, and lastly the miscellaneous uh, amount is about 1,000 ringgit for cost estimation. Now, let's look for financial analysis and economic strategy. Our project starts with an initial investment of 8,000 ringgit Malaysia. We are dividing this money very carefully, which is for the three stage. First, for 5,000 ringgit Malaysia goes to purchasing and renovating our factory lot. Next, for 15,000 ringgit goes to our initial equipment and molding tools. The other 15,000 ringgit is kept completely untouched as a cash reserve. This gives us a 3 month safety net to keep the business stable during our early sales phase. Next is our break-even strategy. Our monthly cost labor is about 6,000 ringgit. To maximize this, we are investing 7,500 ringgit into automated machinery. This automation allows our same labor team to produce 3 times more panels. Since our main raw material is fly ash, there is a zero cost manufacturing waste. This produces a higher volume drastically lower our cost per panel. This push our break-even point much closer. Finally, for our payback period and IRR, our low monthly operational cost of 8,500 ringgit and free raw materials mean high profit margins. This allows us to recover our 8,000 ringgit Malaysia investment quickly, minimizing risk for any for the investors. With direct panel sales and potential waste management partnership, this project ensures a highly competitive internal rate of return.
Moving on to the engineering economic analysis. The project requires an initial investment of 80,000 ringgit with an estimated monthly operating cost of 8,500 ringgit. Based on these figures, the project is considered financially feasible for a small scale production. One of the main advantages is the use of fly ash, which is a waste material. This helps reduce raw material cost and also can improve the overall cost efficiency. In addition, the project has a relatively low setup and operating cost, which making it easier to sustain over the long term. And also these cost advantages also provide flexibility in product pricing while maintaining the good profit potential. Therefore, from both financial and industrial perspective, the project shows a strong potential for future expansion and also long-term economic sustainability. That's all from me. Thank you. I'll pass this to the next person.
Next, let's look at section 3, the market potential and innovation of our product. Our first big adventure is our tool value positioning. So as we know, the traditional bricks makers use up natural resources like clay and sand. We do exact the opposite. We upscale industrial fly ash from landfills. This means we are not just manufacturer, we are an active waste management solution. This makes us highly eligible for government, environmental grants, and green funding. Our second advantage is offering a dry construction solution. As we know, traditional brick walls require laying, plastering, and days of drying. Our composite panels can be installed easily in just a few hours. This saves contractors an immense amount of time and cuts down their heavy labor costs. Lastly, do we compare the existing market solution like plywood or the drywall? Yes, by mixing fly ash with our special binders, we offer superior material features. So, firstly, plywood and drywall absorbs water and rots, but our panels are 100% waterproof. Secondly, fly ash is a natural non-combustible, giving our panels excellent fire resistance and heat insulation to lower energy bills. Third and lastly, unlike the plywood, which is only used for walls, our product is highly versatile and works perfectly for both walls and flooring. By solving real contractor problems and help the governments to reduce the environmental effect, our panels have massive potential in the modern construction market. So that is from me.
In the business potential of this project, we have four important points. First is diverse revenue stream. So
For this point, it is multi-channel income from scalable standard sales, premium custom client orders, and strategy waste sourcing elements. The second point is high customer value. So for the lightweight, ultra-durable panels, lower shipping and upkeep costs while actively helping the clients to achieve the ESG target. The third point is strategy feasibility. It is perfectly balanced the technical reliability, which is the advanced processing, with financial scaling, uh, which is the economies of scale while low cost waste. The last point is environmental impact. It is drive the circular economy by repurposing plastic garbage into a sustainable, long-lasting construction alternative. So in conclusion, this project proved that transforming industrial fly ash into construction panels is both technically and financially viable. By balancing solid engineering with effective project management, we will develop a sustainable building material that reduce environmental waste while creating a profitable market-ready product.